Welcome to Thompson Coding Series. In this series, we'll be talking about web development fundamentals. Now, what do we mean by that? So we'll be covering the basic knowledge of what you need to know about developing web applications and how web applications function. So in the series, we'll be talking about the foundational knowledge required for you to start your career in developing web application. Let's delve into the series and see what it offers. Now, so in this series, we'll be talking about the basic terminologies, about most of the concepts in web development and their meanings. The very first thing I want us to talk about is Open Systems Interconnection, normally termed OSI. So what is OSI? OSI is basically a model, alright? It's a model that defines the modus operandi of how systems connect over a network or how systems communicate over a network. So it is basically a set of standards used by computer systems for communication over a network. It is a reference model that comprises of 7 layers, and they include the application layer, the presentation layer, the session layer, the transport layer, network layer, data layer, and physical layer. In these layers, application or data undergoes several changes from one layer to another before being transmitted to another system on the other part of the network. So OSI is a generic model that specifies how communications should be structured on a network. The very first component or the very first layer we're going to talk about is the application layer. The application layer is concerned with end-user softwares such as browsers and applications that interact or are used to communicate with a server over the network. In this layer, there are protocols that define the rules of engagement. One of such protocols is HTTP. HTTP represents Hypertext Transfer Protocol, which is predominantly used by browsers to communicate in a client-server relationship with a server over the internet. Other protocols such as FTP, POP, SMTP, and domain name system live in this layer. At this layer, data is considered as an application protocol data unit. As I earlier said, data is being transformed from one layer to another in a typical OSI model. And the OSI model specifies the format and the definition of data at each of its layers. The next layer is the presentation layer. At the presentation layer, application protocol data units are transformed into presentation protocol data unit. So the presentation layer here ensures that data is in a usable format. The session layer is considered the client-server connection manager in a typical connection or communication over a network. It manages the communication channels, ports, and sessions used within these channels. At the session layer, data is transformed into a session protocol data unit, and it is transmitted to the next layer. The next layer in OSI is the transport layer. Data format, which is a session data protocol unit gotten from the session layer, is broken down into segments at the transport layer. Typical protocols at the transport layer include the transmission control protocols and the user datagram protocols. When data leaves the transport layer, it is transferred or transmitted into the network layer. At network layer, data is transformed from segments into packets. The network layer decides the medium to transmit this data or this packet. The data from the network layer is handed over to the data layer. The data layer is responsible for managing a connection between two physical nodes on the network. It defines the data format on that network. It breaks packets into frames at source and reassembles them back at destination. Once that is defined, the data layer hands over the data or the information or the format of data to the physical wire or wireless connection for it to be transmitted over the network. So what is the basic data metamorphosis that exists between these layers in the OSI model? First, as I earlier said, at the source here, we have data transformed from the application protocol data unit to the presentation protocol data unit, and from the presentation protocol data unit to a session protocol data unit. From session protocol data unit, it is transformed into segments. So at the network layer, data is actually considered as segments. From the transport layer, it's transformed into packets at the network layer. From the network layer, it is transformed into frames, and from frames, it's transformed into bits in the physical layer. All this transformation happen at source. When data or information or whatever communication message we transfer over wire reaches its destination, which is usually in the form of bits, the bits are retranslated back into frames, and frames are retranslated back into packets, packets retranslated back into segments, segments retranslated back into session protocol data unit, SPDU translated back to PPDU, and PPDU translated back to APDU, which our applications actually consume. So this is a typical data metamorphosis that happens between two systems in a simple network connection. And this is what OSI defines. So the next model we are going to be considering is the transmission control protocol and the internet protocol known as TCP/IP. So what does TCP/IP represent? TCP/IP is basically a model. It contains a set of communication protocols used by computer systems for communication over the internet and similar networks. It is a reference model that comprises of 4 layers for how systems communicate over the internet. It is a functional model designed to solve specific communication problems based on standard protocols. Now, the 4 layers of TCP/IP include application layer, transport layer, internet layer, and network access layer. At the application layer, the TCP/IP consolidates the top 3 layers in the OSI model into one. It consolidates the application layer, the presentation layer, the session layer into one layer called application layer. It maintains the transport layer. It also maintains the network layer, but terms the network layer as internet layer. Then it consolidates the data access layer and the physical layer into a network access layer. The driving model for internet communications is the TCP/IP model. There are a whole lot of protocols that exist in the TCP/IP protocol set, and predominantly used ones are the HTTP, SNMP, DNS, Telnet, SMTP, FTP, RIP, and POP. These protocols exist for applications to communicate over the network. At the transport layer, we have the TCP and the UDP. TCP Transmission Control Protocol, UDP User Datagram Protocol. At the internet layer, we have the Internet Protocol. We have the version 4 and the version 6. And we also have the Address Resolution Protocol, usually termed ARP. We have the ICMP and the IGMP protocols as well. At the network layer, we have the Ethernet technology, which is a protocol, Ethernet protocol. We have the ATM, we have the token ring, and we have the frame relay. The TCP/IP protocol suite defines the protocols that are applicable in each of its layers. What is a protocol? A protocol is a set of rules that define how data should be formatted, processed, and transmitted. If you look at data metamorphosis, you will see the transformation and the format that data has undertaken to be transmitted over a network. And that is what the protocol actually does, to define the format of data and the rules, the guidelines for it to be transmitted, as well as defining the rules of engagement for two systems to communicate over a particular network. So let's have a gross consolidated evaluation of both the OSI model and the TCP/IP model. We can see that the OSI model has 7 layers, and we use color disparities to actually aggregate components of various layers to how they are represented in the TCP/IP model. The TCP/IP model has 4 layers. In the TCP/IP model, we've also highlighted the protocols that exist in this model that are also mapped or related to the OSI model. This is vital for your knowledge. Since a web application is actually an application, we are going to be utilizing the application layer. Web application development concentrates on softwares or applications that live in the application layer. So it's basic for you to understand the protocols that exist in this layer for you to establish communication between two systems over the internet or over a network. That brings me to the next thing we need to talk about, the client-server analogy. So what actually is a client-server relationship or client-server communication flow? Typically, you have a network, and fundamentally, the most vast network today is the internet. And you have a bunch of devices, laptops, desktops, mobile devices, IoT devices on the left side of your screen. These devices are usually considered as clients. They all access the internet in most cases or some form of a network. Now, do they access the network to actually establish a communication with another system on the other part of the network? And those systems, or that system, is mostly termed as a server. So a server actually is a resource machine that supplies information, data, resource to its client. So a client-server analogy represents the use of devices to connect to a network, to communicate with another computing devices on the other part of the network. So this is a typical representation of a client-server analogy. The next thing we would want to consider is that the client-server analogy can also exist between servers on the other part of the internet. For instance, we have a web server, and we could also have a database server. In that relationship, the database server can be said to be the server, and the web server can be said to be the client. So what do I actually mean by that? What I actually mean is that a client-server analogy can also be represented or can also be said to exist between servers on the other part of the internet. Now, what do we mean in more detail? In most cases, a server can actually be a software. So they can always be a software-to-software communication or a machine-to-machine communication, where one software is actually the client and the other software is actually the server. Or as represented in the diagram on the right part of the screen, you have a web server, which is a machine, and a database server, which is also a machine. A client-server analogy can also be represented using software-to-softwares or machine-to-machine. So fundamentally, the machine that issues a request is actually termed the client, and the system or the machine or the software that issues a response is usually termed the server. This knowledge is fundamental in web applications, because the typical analogy in web applications is of a client-server analogy. Like I earlier represented, in the real world today, we have what we call the cloud. And the cloud represents a group of servers. It could be one, or it could be a collection of servers, and it could also be a collection of data centers functioning as one unit. So the cloud becomes the other part of the relationship where clients actually connect to over the internet. So that is the basic knowledge for us to understand, and that is vital for you to understand when considering developing web applications. And what actually is a server? Let's quickly dive into the meaning of what a server is. A server is basically a software or hardware that provides resources such as data, services, or programs to other computers. The programs or the computers or systems that it provides services to are referred to as clients. And this happens over a communication channel, in most cases, typically a network. So basically, a server is a computer or a software that provides information for the computing devices, which are called clients, using a request-response approach. So we have a typical client on the same screen. which issues a request to the server, and the server issues back a response to that request. And typically what we mean by a client-server communication or a client-server flow. The next thing we will talk about is a client request and a server response. Because we made mention of request-response analogy, what do we actually mean by that? A client request is simply a request. A request can be as simple as access request, data request, resource request, or any other form of request. Most times it can even be an authorization request. So you have a request, your system, your laptop, your desktop, your mobile device issuing a request over the internet. Now a request must be properly defined for it to get a response. It therefore means that there can be a bad request. Absolutely yes. So to avoid making a bad request, there are standards for defining request. Obviously there are standards for making requests over the internet, absolutely. Or just as there are many types of requests, there are standards that define the structure of some specific request. Typically, request definitions include request type, request protocol, request port, request method, request body, and any other form of information vital. Just as there are client requests, there are also server responses. So a server response is typically a response to a client's request. A response can be as simple as a notification response, a data response, a resource response, or any other form of response, or a document response. So server sends a response. A response also has a definition. It therefore means that there can be a bad response. Absolutely yes. So to avoid making a bad response, there are standards for defining a response. Obviously, there are standards for defining responses over the internet. These standards define the structure of responses. Typical response definitions include response type, response protocol, response port, response header, response data, response status, response body. In some scenarios like that. Let's keep drilling in. Client-server communication protocols. What are they? Client-server communication protocols are standards or rules that govern the request-response analogy. To establish connection and communication to servers, applications rely on protocols. The underlisted protocols in the application stack provide means and definition for establishing such communications. So typically, if you remember the OSI model and the TCP/IP model, we had application layer. The application layer is a home or a layer that houses a whole lot of communication protocol, such as HTTP, which is the most widely used hypertext transfer protocol, SNMP, FTP, SMTP, POP, Telnet, and the rest of the protocols. So we keep saying protocols and protocols and protocols. What are actually protocols? What do we mean by protocols? Protocols are merely guidelines, merely rules, standards that govern communication. A protocol is a system of rules that define how data is exchanged within or between computers. Communications between devices require that devices agree on the format of the data that is being exchanged. The set of rules that defines a format is called a protocol. This is according to the Mozilla Developer Network web documentation. So you have the application layer and you have the protocols. Hypertext Transfer Protocol, what it is. HTTP is the most widely used protocol on the internet. According to MDN Web Docs, HTTP is a protocol for fetching resources such as HTML documents. It is the foundation of any data exchange on the web. So the predominantly used protocol on the web is actually HTTP. So HTTP relies on concepts like resources, uniform resource identifiers, simple message structure, and client-server communication flow. That is why we're talking about protocols. So for client-server communications, a lot of client-server communications out there, they actually rely on HTTP. So HTTP is the analogy or the protocol that defines a typical simple client-server communication on between the browser and your laptop and the web server sending a response to your browser. So let's have a good knowledge of this. Before proceeding, let's go to Google. Let's do this. You see that on this part of the screen, we have HTTPS. This is the secure layer of HTTP. It means this is the secure hypertext transfer protocol. So that is what is the typical de facto communication standards for browsers. So what's the HTTP analogy? Let's drill into it. So typically, let's consider this. You have a web document that you send a request for, all right? And the request travels over the internet. It connects to a web server and it gets a response. Now, when the web document arrives on your screen, here's some things you notice. You notice that it is loading. Let's do an analogy on CNN.com because that is a heavy resource and it actually takes time to load. Just watch this out. This is actually loading resources. You see the images start coming in one after the other. All right, but this is super fast this is a bit fast because of the network. So all the images and the functionality come in a split second. In milliseconds, they are all loaded. And it's still not done loading because it's still consuming resources from the server. Let's have a look at this. You notice, look at the network. You'll see that it is still going to consume a lot of resources. It's still consuming resources. Sending requests and getting response from the server. Obviously it's done. That is why it is the signal here or the session signal here actually stopped, or loading signal here actually stopped, because it's just gotten all the resources it wants. All right, so that is typically what happens. And if you notice very well, you have a plain text here, you have a document here, you have an image here, a GIF image, you have another GIF image, you have an XML HTTP request, etc. And you have different forms of data and they're all loading. This request is ongoing. Let's look at something else. Let me do something else. So let's look at the side of the screen. As I load on world news, it is still loading, and you see that not all the components of the pages are loading at the same time, because the browser gets the first page and the rest of the pages start, components of the pages still coming. All right, so this is typically what happens in HTTP communication. So let's go back to our application. Sorry about this, let's come back here. So that is what happens when you have a web document and every other files from that web document are coming into your application. That is what actually happens. That is what you get. So the first page lands and every other component starts fusing into the application. This image is from the developer Mozilla documentation, and I thought it wise to share so you can have a good idea of actually what happens when you send a request and the response, and how the different components on your web documents keep issuing requests to get the different parts of the web document for it to be displayed on your browser. So the next thing we are going to talk about is the traffic flow. So traditionally you have clients, and most times clients use a user agent like I did on the browser. The browser is actually a user agent. So the user agent is a tool that is primarily used that performs or acts on behalf of the user. It may also be a program that developers use to troubleshoot the applications. Absolutely correct. So you have clients, and the clients usually connect to a proxy. And what are proxy? What is a proxy? Dominic, you said server, and now you bring in proxy. Proxies are actually very required. Proxies are systems and machines that relay HTTP messages between user agent and a server. That's basically what a proxy is. They may be set up to perform a considerable number of functions such as caching, filtering, load balancing, authentication, logging, and a whole bunch of functions on behalf of your request, of a request. So in addition to that, they relay the messages, or they relay the HTTP request back to the server. And the server also sends responses through this proxy back to the client. So servers serves a document or resource as requested by the client. It appears like a single machine virtually, but may actually be a collection of servers sharing the request load. So typically a request originates from an entity. In most cases, a user agent, as we did on the CNN query or on the CNN request. So in most cases, a user agent, which is the browser, the Chrome browser I'm using. In most cases, a user agent can be a browser, absolutely, or anything, a robot that crawls the web for search engine. When the request arrives, the server, it handles it and provides an answer called a response. Let's have a look at that analogy of a web agent. I'll drill into my application or into Chrome and issue a request. The first request I'll say is programming. Look at the request, look at the number of requests that is going behind the scene. Programming with, let's use the word .NET Core. And I hit enter. Check out this portion of the screen. You will notice that their requests are still loading. They are still loading. Look at how the horizontal or the vertical navigation bar is decreasing to show you the number of requests that are actually loading. Different requests are actually loading. All right. So that is coming from a variety of sources. All right. So I did search term. This is the initial query I sent out. Go in there and and let's have a look at the header. All I need is Google. I need you to tell me programming with .NET Core. All right. And the request method is get, and the status code is 200. And I hit that request. All right. And that is typically my request. My authority, the main entry is google.com. Method get, path, do the search. And this goes out there and grabs a whole bunch of responses. All right. Let me not confuse you with that. And it displays them on the page. And all this are information from different sites. So this is actually done by a robot. Usually we call them crawlers, web crawlers. And that is what we refer to in this context. So you have, however, in predominant scenarios, there are a lot of entities collectively called proxies that perform series of operations on this request. They act as gateways and caches. So what is a cache? Cache is a component that stores HTTP response temporarily so that it can be used for subsequent HTTP requests as long as it meets certain conditions. That is according to MDN web documentation. So that is what a typical traffic flow on the HTTP protocol looks like. The next thing we are going to analyze is the HTTP request. So typically a request has a method, which we saw that, and this is the method in the Google. For instance, when we did the search, you notice that I did the search. If you click on it, and you could come to headers, and you notice that the request method here is get. All right. So that is one of the properties of a request. And another property of a request is that it has a path. The path is the URL resource to access, with context-related elements stripped, the protocol, domain, and TCP port. So if you come here, you notice that in this request, you have a path. The path is just search. No protocol, no domain. This is the domain, just the protocol. All right, that is what the path actually is, and that is what a request. Well, that is one of the properties of a request. The next thing is the HTTP protocol version. All right, so which protocol version are we using? We are using, let's come here, request headers. We're using HTTPS. That is the protocol, but I'm looking for the version number. Obviously not shown here, or maybe I cannot see it, but you can see some other information. You can see user agent, you can see other headers. Look at these are all headers that define this request. All right, so this are typical information you have in a request. That is not what we want to do here. Let's go back to our protocol. So as a protocol version has optional headers that convey information for the servers, has some body for some HTTP methods carry some body in their request, like a body. What do I mean by body? Let me check whether this request has a body. Obviously it does. There's no body here, but I could show you a body in payload. All right. Query parameters is using the Let me see the response. The response has no. 1 second. Let me check something. Google has a way of actually performing. All right, I think I would do. Don't worry. If you want to see the body in the whole request analogy, check out one of my series. For instance, ASP.NET Core series. You have a good idea, or .NET Associates series. You see a typical representation. So we have, according to Mozilla, we have method, we have path, we have version, like listed there, we have headers. And that is typically how a request is usually. What is a HTTP response? A response consists of a protocol version, the status code indicating the status of the request. For instance, when we did this, the response had, let's come back to headers, and you had response status code is 200, and that was the response. All right, that is a response information and indicating the status of the request. Let's minimize all this so you can have a good idea. Status, you see all this request here have 200 status. All right, so that is what status or status code actually is. So it has a status message, a non-authoritative short description of the status code, HTTP header similar to those of the request, a body that contains the fetch resource optional, and that is the typical analogy of how a HTTP response actually looks like. So the next thing is HTTP driven APIs. Okay, well, there are some HTTP driven APIs that we need to know. Number one is XML HTTP request. This API means application programming interface, and this is what is used to perform programmatic logic operations on the browser. So XML HTTP request is used to exchange data between a user agent and a server. All right. And another thing we have is Fetch API. Fetch API is actually another way of communicating to the server. It's similar to the XML HTTP request, but more powerful and flexible. Server events. These allow server sent events. This allows a server to send new data to a web page at any time by pushing messages to the web page. The messages are usually treated as events. So for instance, you see some pop up on your screen, you said allow notifications for this. So once you're on your system and you open your browser and you see these notifications pop up by the side of your screen, those are server sent events. All right, so that's typically, just don't worry about that. If you're a front-end developer, you will actually do a lot of that and you actually use all these APIs. So let's talk about user agents, front-end, back-end components and their purpose. All right, let's go ahead and talk about this. So typically by now we know what a user agent is. It's basically a browser. All the browsers out there are actually user agents. So they allow you to connect to a server and perform some operations or some queries on it, as we did on the Chrome browser. All right, so we have Microsoft Edge, we have Chrome, we have Firefox, we have Safari, we have Opera, and a whole bunch of browsers out there. Another thing we should talk about is web servers. What are web servers? You already know what the server is. Server, when you send a request, the server responds to your request. So we have Apache, we have Nginx, we have IIS, we have Kestrel, we have the Flylight server, we have Mongrel, we have Oracle, we have the Unicorn, and you have WAMP. These are all servers. All right. So a whole lot of the applications you're accessing there, Google, they're actually hosted or saved by web servers. All right. So that's it. And let's talk about front-end technologies. What happened on the front-end technologies? Front-end technologies has to do with technologies that happen on the browser. Typically, that is what it meant. And you have browsers. Browsers are software programs. Traditionally, they are software programs that you have to install on your desktop, on your phone, on your mobile devices, or on your laptop. These are browsers, and they're software programs. And traditionally, they have a group of technologies associated with them. Number one is HTML. HTML means Hypertext Markup Language. It's actually a web document. It's a standard markup language for documents designed to be displayed in a web browser. So the markup language for a web page creation is actually HTML. The next one is Cascading Style Sheet. It's a style sheet language. Cascading Style Sheet is actually termed CSS. It is used for describing, styling the presentation of a web document or pages written in HTML or XML. So for instance, traditionally, I did a request. For instance, let's come to the Google. Look at the raw response from this object. This is the response. This is actually a HTML document. But users don't understand what this is. Users actually see this. So this is what the browser sends. This is what the server sends back. The browser interprets this and presents it like this. So this is a traditional, natural HTML document. But what adds this beauty and presentation that makes it readable is actually CSS that does that. Okay, so CSS is a styling language, style sheet language for XML and HTML. All right, let's continue. The next thing we have is JavaScript. JavaScript is a programming language for the web. It's the web programming language. Browsers have JavaScript runtime that execute instruction logic on the web or on web documents and pages. Let's have a look at it again. So for instance, I want to go to JetBrains, for instance, or I want to open this video here. I could click this. When I click this, something actually happens. Check this out. I click this, it loads JetBrains resource, and that is loading, and this changes to JetBrains. What makes that happen? How did the browser know that? JavaScript was responsible for executing that instruction, navigating from Google to JetBrains. That is what JavaScript does. All right, and here you notice that it was able to make another request. If you can, let's drill into JetBrains regress, and I think the very first point is that you have this document. This is the document. Now let's come here. Doc type. This is actually a web document, but that is not. Users cannot read or interpret this, but users can actually read this. All right. So this is, and they have a CSS that actually tells what this page is actually about. So you have the script and a whole lot of bunches which users cannot read, but users can read. Rider, fast, powerful, cross-platform .NET IDE. You can actually read that. That is what these three technologies help to do. Perform logic on the web, make it presentable for you to read, have a definition for the structure of the document you need to read. So HTML is like defining the structure of the document, like building a house. CSS is like putting beautifications that add value to reveal what is this house. It's actually a bungalow, a duplex with white, green, brown colors with tile. Yeah, that's what CSS does. And JavaScript brings the smart home automation to that house. That is what basically happens. So how do browsers do this? So browsers traditionally have HTML parsers. The HTML parser evaluates the HTML syntax to ensure appropriateness and how to define the document object model. Alright? Now, browsers also have a CSS parser. The CSS parser evaluates the CSS syntax to ensure its appropriateness and how to define the CSS object model. And finally, they have the JavaScript runtime. So typically browsers have these three fundamental programs or runtimes embedded in them. So what actually is a parsing? Or what actually does parsing means? Parsing means analyzing and converting a program into an internal format that a runtime environment can actually run. Alright, so this is what front-end technology is focused on. And as a front-end technology developer, you need to understand that. So how does the web or the browser process HTML? So browser loads HTML, receives from the network. It converts the HTML into a document object model, which is called DOM. The DOM represents the document in the computer's memory. The browser then fetches most of the resources that are linked to the HTML document. Remember the analogy we did on the CNN website? Alright, that is what it does. The browser passes the fetch CSS and sorts the different rules by their selectors types. Don't forget about those details. And applies them to the nodes in the DOM and attaches a style to them as required. The render tree is laid out in the structure it should appear in after the rules have been applied to it. The visual display of the page is shown on the screen. This stage is actually called painting. This details, actually I got it from MDN, Mozilla Developer Network. So let's look at the image here. The image on the right tells us a whole lot. So your browser gets a HTML, it loads the HTML and it parses the HTML. The server responds with the HTML, it parses the HTML to create a DOM tree. As it's parsing the HTML, it realizes there are cascading style sheets in it. It loads the cascading style sheets and it starts parsing them. On formulating the DOM tree, it injects the styles required at the appropriate nodes in the DOM and pins the display for the users to see. That is what actually happened when we're loading the CNN channel. So to explain that analogy again, you can actually close this and come back here and actually load that again. But this time I would like this to be, the F12 should be on so you can actually appreciate that. And we can say cnn.com and let's see what happens. So this is the web document we are requesting from, and that is loading. It's loading the different images. Immediately we got this web document, I will show you something that happened. So this web document was first loaded, and the next thing that we got was was a script. And probably let's analyze this document. Let me show you something. This is coming to open this here. Sorry, that is not what I want. I want the headers, and let's come in here. That tells me more, and let's check out the response and look at this. This loads style. Okay, so these are typical style sheets that actually brought in when the application was loading and they used in painting. So this actually is referred to as painting by the browser. Okay, I believe you understand that by now. Let's move on to something else. So the next thing we're going to talk about is, as a front-end developer, what do you need to know? You need to understand, you need to learn and understand how to work with HTML, cascading style sheet, and JavaScript. That is your job as a front-end developer. All right, you need to know how to do it. In fact, you need to how to know most of the JavaScript, prominent JavaScript frameworks like React, Angular, Vue. There's a new one I stumbled upon called, I think, Quick, something like that. So you need to know how to use those resources to actually work on browser, build browser-oriented applications, all right, or browser-native applications. So that is what you require. Let's head over to another section. Let's talk about server technologies or backend technologies. So we have the backend technologies or server technologies, like you have Apache, Nginx, RS, WAMP, Oracle, Mongrel, Unicorn. That's fine. And you have web application development languages. You have JavaScript also as a web application development language for the backend. You have Python, you have Ruby, you have Java, you have PHP, you have C#, you have Perl, you have Golang, you have C++, you have Scala, you have Kotlin. These are web application development languages, meaning that you can develop applications, web application, in any of these languages. And a web application is basically a program stored on a web server that utilizes browsers and web technology to perform tasks over a network. A web framework. Now, predominantly, web applications are actually developed using web frameworks. Not that we cannot build web applications without a framework, but a web framework provides you with a set of resources and tools that support in the development of a web application in a very fast means or a faster means. So what are the web frameworks out there? So we have Laravel, we have Express, we have Flask, we have Ruby on Rails, we have ASP.NET Core, we have Spring, we have Django. These are all web frameworks on different programming languages. And we have the server programming language runtime. So your web framework requires to be running or hosted on a particular runtime on the server. And we have Node.js runtime. That is for JavaScript. We have .NET Core runtime, that's for ASP.NET. We have the Java runtime environment for Spring application. All right, so these are basic knowledge of the things you need to understand. And as a back-end developer, you need to know either of these. You need to know at least one web application. You need to programming language. You need to know how to work with one framework, and basically, and how to host that framework on a particular or specified runtime. So those are the things we need to understand when delving into web development. Classifications of web applications. What are these? All right. This approach for classifying web applications is strictly developer-oriented. Let me say, software engineering perspective of a classification, not the one you Google classifications of web applications. This is actually typical. Now, typically I categorize web applications as follows: server-based web API. When I say API, I mean application programming interface, also known as REST API or RESTful API. The second one is server-side rendered user interface web application. And the last one is client-side render user interface web application, also known as front-end application. So these are my typical classifications of web applications. Whether it is a static web application, whether it's a dynamic web application, whether it's an e-commerce web application, it falls under these three. All right, and that is what I wanted to share. So let's analyze the server-based web API, also known as a RESTful API. These include a set of protocols and tools that facilitate interaction between two different applications. Basically, this type of applications permit interaction between two systems. Okay, so traditionally there are interfaces that allow the outside world to communicate with the business logic of an application. Fundamentally, these interactions are often carried out at specific digital locations known as endpoints. Alright, so let's go back to Google again. By the way, let me show you something. That is too much grammar and that is a little bit complicated. I want to show you something. So for instance, this path rider is actually an endpoint. Alright, so let's go back to Google. Let me do this, google.com, and you see the path, and let's click here, not here, sorry, that is still loading. Let's click here and you see this path. This is actually, we could tell this to be some form of a path, which is an endpoint on this system, and that is basically what it is. Fundamentally, these interactions are carried out at specific digital locations known as endpoints. If you want to have a good idea of how to build endpoints, pick up any of my series. The .NET Associate series has definite information about it. Just go to Thompson Coding series and you'll have a whole bunch of stuff to learn there. So an endpoint is considered to be a point of entry in a communication channel when two systems are interacting. It is the location exposed by an API to process request and send response. That's what an endpoint is. So you have an application, say A, you have an application B, which is a RESTful application. It exposes an endpoint that allows application A to interact with application B. Right? Types of server-side rendered application. These are applications developed and rendered on the server. Basically, that's what server-side applications are. This was a traditional approach for websites and web applications. All the process involved in creating web HTML page that your browser can, all the processes involved in creating a web document that your browser can understand are handled on a remote server hosting the web application. This includes querying databases for information and processing any logic that your web application requires. Most of the presentation logic are orchestrated on the server. When a browser sends a request, it remains idle and waits for the server to finish processing the request. When the response is gotten, the browser interprets and displays the content on the screen. So you have a browser, a request is sent, the server to the server application server, the server processes the request, and all the logic required to create a web document sends the created web document to the browser. So that is what happens in a server-side render user interface web application. So the next one is client-side render user interface application, also known as front-end application. These are applications developed and rendered on the browser using the de facto programming language of the web, which is JavaScript. The browser is responsible for rendering this type of application and its final form. This term was coined for applications that are rendered on the browser instead of the remote server. In this category of application, the presentation and most of its logic are usually managed in the browser, which is the client side. The advent of JavaScript frameworks and libraries such as Angular, React, Vue, Quick, and the rest of the frameworks provided or promoted the development of this type of applications. So you have the browser, which connects to an API server, and the request, the processes, all what is required to manage the logic is on the browser, not on the API server. So you can have an API server which provides an endpoint for front-end applications to connect. So basically, the very first type of web application I told you, an API server just does only data, provides an endpoint where other applications can connect and retrieve and exchange in some form of information. So, in my opinion, those are the three categorizations of web applications that are out. So these are references which you can find on the document associated with this video if you're a subscriber or you're watching this on Thompson Coding Series, so you can have access to these resources. And if you want to learn more about how to practically use any of those frameworks, web frameworks, and how to build applications, go ahead over to Thompson Coding Series and enjoy yourself. All right, have a wonderful day. Thank you for listening. All right, class, bye.